part A, we need to do a Riemann sum, which is represented here by definition number 5, where we know that m equals n, which is equal to 2, and we need to evaluate this double integral, which describes f of xy to be equal to x times e to the negative x times y. And r is represented by these coordinates, which we can rewrite into interval notation to show that x is bounded by 0 and 2, and y is bounded by 0 and 1. And our sample points are the upper right corners. So first, we need to find out the widths and the lengths of our rectangles in our Riemann sum. In order to do that, I'm going to take the endpoint subtracted by the start point for each of our variables and divide it by its m or n. So for x, 2 minus 0 over 2 is equal to 1. This is our length, or delta x. For y, I'll do 1 minus 0 over 2 is equal to 1/2. This is our height, or delta y. And now we can find the area of each rectangle to be 1 times 1/2, which is just equal to 1/2. And now we need to figure out the upper right corners of each of our rectangles. So I'm going to start our rectangles from the minimum x and y value, which is going to be 0, 0. And they're going to have a length of 1. And a height of 1/2. Such that the upper right corner will therefore be at 1, 1/2. And now I will continue adding our delta x until we form a rectangle that's outside of the x bound. So our next rectangle will be at 2, 1/2. But if we add another delta x for 3, 1/2, this rectangle will be outside of the bound. So we do not include this point. Now, then I will add the delta y values to each of these coordinates until I form a rectangle outside of the y bound. So I will have another rectangle at 1, 1 and at 2, 1. So these are going to be our 4 coordinate points for our Riemann sum. Now we can plug in all our values into definition 5. This double integral can be approximated by the summation from I equals 1 to 2, and the summation of j equals 1 to 2 of f x sub I y sub j times 1/2. This summation will equal f of 1, 1/2 plus f of 2, 1/2 plus f of 1, 1 plus f of 2, 1. And this will be times 1/2. So if we plug this into our f of x, which is x times e to the negative xy, we will get the summation to be equal to e to the negative 1/2 plus 2 e to the negative 1 plus e to the negative 1 plus 2e to negative 2. Now this can be simplified to e to 3/2 plus 3e plus 2 over 2e squared, which is also equal to 0.990. And that is our answer for part A. For part B, we need to figure out 4 midpoints of each rectangle. So again, starting with a rectangle at 0, 0 with a height of 1/2 and a length of 1, this rectangle will have a midpoint here at 1/2, 1/4. And if I add another x, I will get 3/2, 1/4. And if I add my delta y, I will have 1/2, 3/4, and 3/2, 3/4. So those are our 4 midpoint coordinate points. And we're going to plug this into our midpoint rule here, so that the double integral of our function can be approximated by the summation of I equals 1 to 2, and the summation of j equals 1 to 2 of f x bar sub I y bar sub j times 1/2. And this is equal to the sum of f 1/2, 1/4 plus f 3/2, 1/4 plus f 1/2, 3/4 plus f 3/2, 3/4 times 1/2. And this is equal to 1/2 e to negative 1/8 plus 1/2 e to negative 3/8 plus 3/2 e to negative 3/8 plus 3/2 e to negative 9/8. And this can be simplified to e plus 4e 3/4 plus 3 over 4e to 9/8, which is also equal to 1.151. So this will be our answer for part B.